Today we are going to solve linear systems in 3 variables. This means that we have 3 equations with 3 variables, x, y, and z. Our final solution is going to be written as an ordered triple. So instead of an ordered pair, it's an ordered triple. That triple is x, y, z. So the first blank is where we're going to write what x is. The second blank will write what y is. The third blank will write what z is. This requires you to keep your work very organized. It's a multi-step process. We basically need to eliminate a variable, eliminate that same variable again, and then eliminate to get to one variable. I like to label my equations. You can label them with letters or with numbers. I think it might actually be easier to label them with letters. So we'll call this first one equation A, the middle one equation B, and the third one equation C. Before you start, I want you to look at what you have. I see an x and a negative x. So I know right now we could eliminate x in the first 2 equations. And then I also see negative x and positive 2x. If I chose those 2 equations, it'd be pretty easy to eliminate x. We need to eliminate x twice. So the first thing I'm going to do is take equation A and equation B, and I'm going to eliminate them. So equation A is x minus 2y plus 3z equals 9. And underneath that, equation B, negative x, that is really annoying me, plus 3y, there's no z, so I leave a space, equals negative 4. Now, do you see how this example is written out and spaced out so that the x's line up, the y's line up, the z's line up? In your book, it won't be spaced like that, or it might not be spaced like that. If you ever see a 3-variable system that is not spaced out like this, when you copy it onto your paper, space it out, arrange it in columns so that everything is in its proper place. Okay, let's take these 2 equations, A and B, and eliminate them. X and negative x, those are going to cancel. Negative 2y and positive 3y, those add together to give us 1y. 3z plus nothing is 3z. And 9 plus a negative 4 is 5. I'm going to take this equation and put it over here on a shelf and save it for later. 1y plus 3z equals 5. Okay, we've done our first step. Our second step is eliminate again. You can choose equation A and C. You can choose equation B and C. You can do this however you want to. You just can't do A and B again. You have to do A and something else or B and something else. I am going to choose B and C. But take a look at B and C. If I use B and C right now, would these x's eliminate? Don't move on yet. What do I need to do to equation B to make those 2 equations eliminate the x? Times 2. So right down here, I'm going to put 2 times equation B. Just a visual cue to myself that I need to take equation B, multiply it by 2 before I write it down here. So 2 times negative x would be negative 2x. 2 times 3y would be positive 6y. 2 times nothing is nothing. Leave a space. 2 times negative 4 is negative 8. Equation C, we're not doing anything to, so I'm going to write that down exactly as it is over on the left. And now we're ready to eliminate. Negative 2x, positive 2x, the x eliminates, that's what we wanted. 6y, negative 5y, that is 1y. Nothing and 5z is 5z, and, sorry, negative 8 and 17 is 9. I'm going to put this one up here on the shelf with the other one. Have you noticed that I put a slash in the middle of my z?
Yeah.
This is the point in math when I started putting a slash in my z, because sometimes when I write 2's in a rush, I don't get the loop in them and they look like z's. And I made enough mistakes where I thought that a 2 was a z or thought that a z was a 2 that I realized I had to do something with my z's to make my z's look like z's and not like 2's. So if you want to start putting a slash in your z's or just doing something so that you make sure you don't screw up a 2 and a z. Okay, we eliminated with A and B. Put that one on the shelf. We eliminated with B and C, we put that one on the shelf. Now we need to take these two equations on the shelf and we need to eliminate a variable. Which variable do you think we should try to eliminate? The y. Is it currently set up for elimination or do we need to do something? If I add these together right now, 1y plus 1y is 2y. We want the y's to eliminate. We want one of them to be negative, so I'm just going to take the second equation and stick a negative in front of each term. That's the same as multiplying each term by -1, and it doesn't require me to rewrite everything. You know, strategic laziness here. Now I'll add them together. 1y, -1y, that eliminates. That's what we wanted. 3z, -5z, that will give me -2z. And 5 plus -9 is -4. Finish solving. Divide both sides by -2, and we get z is 2. So I can go over here to my answer area and put in the z blank that z is 2. Okay, I'm going to stay in this third column of work over here. We need to pick an equation that has only z and one other variable so that we can figure out that other variable. I don't really want to deal with these bigger numbers or the negatives, so I'm going to pick this equation, 1y plus 3z equals 5, and I'm going to put that 2 in so that I can figure out what y is. So 1y plus 3 times 2 is 6. Subtract 6 on both sides. I get y equals -1. So over in my answer area, in the ordered triple, I can write -1 in the middle blank, which represents the solution for y. Anyone want to take a guess what you think we need to do now? We need to pick an equation that has x in it that we can plug y equals -1 into and z equals 2 into. Some people like to pick b because there's only x and y, but that negative in front of the x, I don't like that very much. Really, you can pick any of the 3 original equations. It does not matter which one you pick. Personally, I am going to pick x minus 2y plus 3z equals 9. If you want to pick the middle equation, that's fine. You should get the same x value no matter what. And I know that y is -1 and z is 2. So we've got x, -2 times -1 is +2. 3 times 2 is +6. So I have x plus 8 equals 9, which means that x is 1. So the final solution for my system is, 1, -1, 2. X equals 1, Y equals -1, Z equals 2. Okay, to recap everything we did, we started with the first two, eliminated X, put that on the shelf. We picked two different equations, eliminated X again, put that on the shelf. We take these two equations that don't have X and eliminate to get Z. Then we plugged that in to get Y, and then we plugged both of those in to get X. It's eliminate, 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 substitute, substitute. It's just like a five-part problem. No big deal. There are multiple ways that you can go about this. Someone in my last class said, look at the last equation. Look at equation C. Do you notice how it already doesn't have an X? So if we could eliminate X using the first two equations, we could maybe skip some work because we already have another equation that doesn't have X in it. And that is true. Or some people like the looks of this because you could multiply the top equation by 3 and then have 3Z and -3Z and eliminate Z. Then you could choose Z and 2Z, multiply the top by -2. You'd have -2Z, +2Z, and you could eliminate Z again. It's up to you. Do you guys want to do the shortcut of doing less work? Yeah. Sure, let's do the shortcut. So basically what we're saying is we are going to take this equation, 5y plus 2z equals 8, and we're going to put that over here on the shelf and save it for later. And now we're going to take the first two equations and try to eliminate X. But here's the deal. If we want to eliminate X, what are we going to have to do? Multiply both of them, and what's our goal? What number? What do we want our x's to be? 6x and -6x. So we're going to have to multiply this entire top equation by 2 and the middle equation by -3. So I'm going to pause the video, take a moment, multiply the top equation by 2, multiply the middle equation by 3, and then eliminate to get another equation that doesn't have x. A couple of hints. This blank here, you want to keep that as a blank when you're eliminating. Okay, so I now have my two equations that are ready to eliminate. Now I need to pick which variable we want to eliminate here. I like that we have a positive 5y and a negative 2y. I like it when we have a positive negative. What should we try to get these to be if we've got 5 and 2? 10. So we're going to multiply the top by 2 and the second one by 5. So take a moment and do that and eliminate and figure out what z is. Big numbers are okay when you're multiplying equations multiple times. You're going to end up with bigger numbers. When we add these together, oops, I definitely added those wrong. Wow. 236, 59z equals 236. Divide both sides by 59 and x equals 4. So we know that x is 4. This time, oh, not x. Whoa, whoa, z is 4. Go back. Okay, now I want you to pick one of the equations that has y and z. Honestly, if I were you, I would pick this top one. Figure out what y is, and then pick an equation, plug it in, figure out what x is. Keep in mind that the system rules we had before are still in place. So if variables eliminate and you're left with a true statement, it's many solutions. If variables eliminate and you're left with a false statement, it would be no solutions. Okay,